We've covered asymptotes, the different kinds of asymptotes that we can get and how to calculate them. In this video I'm going to give you a couple of examples. What I'd like you to do is look at the questions, work your way through them, and then come back to the video and see the solutions that I've done here. So, here you go. What I'd like you to do is calculate all of the asymptotes of these two functions. Now what I mean is all vertical asymptotes and all oblique or horizontal asymptotes that may exist for each function on their own. So pause the video and have a crack at both these. So the first function was f of x equals x squared plus 3 over x minus 1. Now remember, for any of them, we want it in the form of m of x plus g of x over h of x. And remember, the rule is that g of x, the highest power, has to be less than the highest power of h of x. Now in this case, it's bigger than it, so what we're going to have to do is use algebraic long division to whittle that down. So I've got x minus 1, and underneath I've got x squared. There's no x, so remember what we said before, we fill that in with a gap of plus 0x, then plus 3, because we have to make sure we count that as well. Then we work it through. So x squared divided by x just gives me an x there. Multiply this all by x, and what I get is x squared, take away x, and I subtract them from each other. So I get, that goes, I've got 0x take away minus x, so I end up with x, and then I've got a plus 3. This power here is equal to that, so I do one more repetition of it, and that's me got the answer. So x divided by x gives me a plus 1, multiply this by it, and I get x minus 1 there again, and take them away, what I'm left with is 4. So from that, what I can do is I can say, right, well I can write f of x in the format x plus 1 plus 4 over x minus 1. Now I have it written in this format of m of x plus g of x over h of x, I can look for all my asymptotes. So the first one I'm going to look at is the vertical asymptotes, and remember that's given by setting the bottom of the fraction equal to 0. So if I set x minus 1 equal to 0, I get a solution of x equals 1. So I know I've got a vertical asymptote at the value of x equals 1. I then look at my oblique or horizontal asymptotes, and that's given by the m of x in front. So my m of x in this case is x plus 1. What that means is y equals x plus 1 is going to be an oblique asymptote for the function. So if I was to do a rough sketch of this one here, I know that I'd have a vertical asymptote there at x equal to 1, and I'd have an oblique asymptote which would go along like that, taking the form of a straight line with a function y equals x plus 1. I could then fill in the rest of the space using the function and the values associated with it, but I know I'd have asymptotes at these two sets of values. Second example was this one, so f of x equals x squared plus 1 over x. Again, think about putting it in the format we want it, our m of x plus g of x over h of x. If we look at this, the highest power on top is bigger than that on the bottom, so again, this is where our good friend algebraic long division comes into play. So my x is going to divide into x squared, again, no x value, so I'm just going to put a plus 0x, then a plus 1. And then we go as we normally would. So x squared divided by x simply gives me an x, multiply it through, I get minus x squared. So if I then subtract them from each other, I get x squared take away x squared is nothing, I get 0x, and then I get just a 1. So what that means is I can then take this and rewrite my f of x as f of x equals x, so what I got when I did my division, plus 1 over x. Now that I have it in the right format, I can look at my two sets of asymptotes. So if I start with the vertical ones, again, that's looking at the bottom and setting it equal to 0. Well, that's quite easy. All I have to do is set it as x equal to 0. If x is 0, I'm going to get vertical asymptotes. Then I look in front of it at my m of x, to get the other asymptote, so to get my oblique one. And in this case, y equals x is where my oblique asymptote exists. So again, if I were to sketch this one, I'd end up having an asymptote, a vertical one, up and down the y-axis, so the curve would approach it, but never physically cut through the y-axis. And I'd have another one that was quite simply given by the straight line y equals x. So I'd have my two asymptotes there, so my function would approach it in some way along those. Now what we're going to do is eventually build everything we've done together so that we can sketch functions like this and bring in all these characteristics. But we have to understand about these asymptotes. We have to understand how to calculate them, what they mean, and what they look like.